13-foot ladder is sliding down a wall. It's moving away from the wall. The base of the ladder is moving away from the wall at a rate of 5 feet per second. The goal of the first part of this problem is to find the rate that the ladder is falling down the wall, dy dt. So we know x squared plus y squared equals L squared, x being the distance from the wall, y being the distance up the wall, and L being the hypotenuse of that triangle. So then we can find the derivative of that is this, and then we cancel all the 2's, and then we can plug in what we know. So 12 is x at this instant, x is 12, times the change in x, which is 5, plus 5, which is our y at this instant, times dy dt, what we're trying to find, equals the length of the ladder, which is 13, times the change in the length of the ladder, which is 0. So then we just do some basic algebra. So the change in the height is negative 12 feet per second. It is moving down at a rate of 12 feet per second. The second part of this problem is to find out at what rate the area of the triangle made by the ground, the wall, and the ladder is changing. So first we start with the area of a triangle is 1/2 base times height. Our base is x and our height is y in this case. So 1/2 xy. Then we find the derivative of that using the product rule right here. Then we know all of these, so we just plug everything in and solve it. So the change in, or the rate at which the area of this triangle changes is negative 59.5 feet per second squared. The last part of this problem is to find out the rate that the angle made by the ground and the ladder is changing. So we know that sine of theta is opposite over hypotenuse. So the opposite is y and the hypotenuse is a constant, 13. So sine of theta equals y over 13. Then we find the derivative of that, which is cosine theta d theta dt equals 1/13 times dy dt. Then we know what cosine theta is because it is adjacent over hypotenuse. And at this instant, the adjacent side is 12, and the hypotenuse is always 13. So 12/13 times d theta dt equals 1/13 times negative 12, which is our dy dt. Then we just solve from there, and we end up with the change in that angle being negative 1 radians per second.